All right, so this time we're going to take a look at page 550, number 8, which is asking for the distance between these two lines. So these two lines, they don't have the same direction vectors. So if they're not intersecting or if they're not parallel, and they're asking to find the intersection point between them, then they're skew. So here's a sort of a diagram that we can use to describe these two lines, that they are skew lines. And what we're going to do for this is, in order to calculate the distance between them, we're going to consider them both being in two parallel planes. So two skew lines will always fit in two parallel planes along the lines as, say, a line on your ceiling and a line on your floor going in different directions. It's always possible to do, and that's just the way we'll consider it for this. So in order to construct this plane, what we'll do is we'll sort of imagine that there's going to be a plane that contains this line, and then we're going to look for a point on this plane, and we're going to consider the distance, a point on this plane, and we're going to consider the distance to this plane. Now, I don't actually need this plane up here. I just need a point, and I know a point. This point will, or I know a point, and a point on this plane will be 1, -2, 5. So we're going to calculate the distance between 1, -2, 5 and this plane. To find this plane, I'm going to cross product these two direction vectors in order to get a normal. So if this here is direction vector 1 and this is direction vector 2, then the normal to the planes will be M1 cross M2. Or if we were to do this, I would get -1 and then 1, 0, -1 and then 0, -1 and -1. Oh, isn't that nice? Now -1, -1, -1. Now, along with the point that I know is on this plane, this point right here, then my -x, -y, -z plus d equals 0. To find this d, I'll use this point and get -1 plus 1 plus 2 plus d equals 0. So d equals 3 minus 1 is 2, -2 when I bring it over to the other side. So, did I do that right? I believe I did that right. So, the equation of the plane I'm looking for here is, well, look at that. They're all minus, so it'll just change them all to plus z plus 2 equals 0. That will make things a bit easier. So now I'm calculating the distance from the point, from this plane to the point 1, -2, 5. So distance is going to be equal to, I'll have down here 1 squared plus 1 squared plus 1 squared for my magnitude of normal, and up here it'll be 1 minus 2 plus 5 plus 2. So distance will be 7, 8 minus 2 is 6 over root 3. And I can clean this up. This is going to be 2 times 3 over root 3, which will be equal to 2 root 3. So that will be the distance between the two skew lines. Now, that's part A. Part B is actually asking for the 2 points, 1 point on each line, that are actually the 2 points that create the shortest distance. Now, this is a different problem here. We haven't looked at a problem like this before, but we're going to use a similar tool to what we used before. In order to find these points P and Q, we have to imagine that there's a vector PQ, and that this vector PQ will be perpendicular to both direction vectors. So if there's an M1 on this line and there's an M2 on that line, then the vector PQ will be perpendicular to both. That is, PQ dot M1 equals 0 and PQ dot M2 equals 0. Now this is going to set up a system of equations because PQ will have both S and T in it, and M1 and M2 are both known. So they have no variables in them, so we'll end up with 2 equations and 2 unknowns. We should be able to solve that fairly easily. So in order to get PQ, we need to first have we have to have a P and a Q. Since P and Q are both known points or unknown points on these two lines, then I can use the parametric equations of this line as the coordinates of this point. So these parametric equations are 1, 2 minus s, and 5 minus s for P, 1 plus t. This next one will be minus 1 and minus 2 minus t. So that makes vector PQ 1 plus t minus 1 and minus 1 plus 2 minus s and minus 2 minus t minus 5 plus s. Or t 1 minus s minus 7 plus s minus t. That'll be my PQ. So M1 is given here. M2 is given there. So I'm going to have PQ dot M1 will equal 0. So that'll be 0, 1 minus s plus 7 minus s plus t equals 0. And then using my second equation, so this will be my equation 1, using my second equation will be PQ dot M2. So that'll be t 0, and then minus 1 again, which plus 7 minus s plus t equals 0. That'll be my equation 2. So 2 equations, 2 unknowns. I should be able to solve this. I'll just simplify them real quick and get, excuse me, from the first equation, I'll get 8 equals 2s minus t. And from this equation, I'll get 7 equals s minus 2t. So I'll just call those 3 and 4. And then I'll eliminate a variable s by going 3 minus 2 times 4 and get 8 minus 14 is minus 6 equals 2s minus 2s is 0, and t plus 4t is 3t, so t equals minus 2. T equals minus 2 will give us the value of q, which we want to know. So q is going to be minus 1, 0. And we can go back, sub this t into, let's say 3, and get 8 equals 2s plus 2. So subtract 2, I get 6 equals 2s, s equals 3, and that will give us our value of p, which is 112. Now, on top of all of this, we should be able to discuss the magnitude of PQ as being the distance between the two lines. So the vector PQ, using these two